Hey there, my name's Sam. I'm here with Muddy Math to bring to you 6th grade mathematics through EcoBricks. EcoBricks are a great fun way for your family to get together. My daughter and I love to do this. We make confetti trash with all of our wrappers and plastic. Get a drumstick, stuff our EcoBricks, check the mass of the EcoBricks as we go along to make sure it's within the range of density that we can use to actually build. Our EcoBricks have to be above about 1/3 of the volume in its density, which means if these are 500 ml bottles, 1/3 of 500 is about 167. So these bottles have to be greater than 167 grams, and they need to be less than a density of about 7/10, which 7/10 of 500, well, 1/10 of 500 is 50, so 7/50s is 350. So these bottles need to be between 167 grams and 350 grams. We're looking good. I don't remember which ones went where because I bonked the whiteboard, but luckily I have my gram scale. So for this exploration, this whole series, you're gonna want some sort of stuffing device for your plastic. If you can't really make an EcoBrick, you can. You just need clean trash, plastic bottles, and you're condensing these bottles with the plastic trash that otherwise would have been in the dump, maybe made its way to a river or a stream, or unfortunately maybe incinerated and put into the atmosphere. So grab a gram scale, kitchen scale. They have digital out there. Manufacturers make analog. This only goes to every tens place. So if I were to measure my EcoBricks with this analog analog scale, it would go about 180, 180, 200. When I'm measuring with my ones gram scale, it goes to the ones place, I can get a little bit more of a precise measurement. All 3 of these EcoBricks fit within my range of density. They're all between 167 and 350 grams. These are good to go to start building with. We'll get more into the details of what we could build, why we would want to build, and all that in future videos. But for now, the point of this video is to make sense of density as a ratio. A ratio is a mathematical tool we can use to analyze measurements or counts in our world alongside another. So we're taking observations and measurements with another, putting them alongside each other and seeing what else that tells us about our world. So mass, how much something weighs in grams for our sakes today. Grams isn't the only way to measure mass. And volume, we'll be using milliliters since we have water bottles. They're designed to carry water, can be measured in milliliters. And our density, therefore, will be measured in grams per milliliter. And you hear that word per, you can think of rates. Think when you're driving down the road, kilometers per hour. How fast are you going? Kilometers and hours are measures of distance and time. We don't convert them. In this case, we're not converting mass and volume because we have a variety of plastics and not a consistent density amongst all the plastics. Density is a ratio that compares matter per cubic unit of space that an object takes up or occupies. Stay tuned, click the next videos to complete the chart, to explore this graphic organizer, and to make sense of inequalities and where these values can get plotted along that number line. See you in the next video.